Hi guys, today we're going to take a look at page 17 of your Unit 1 classwork packet. Let's start off with example number 2. So example number 2 gives me two angles, alright, and I apologize if this is not drawn super well. They have a big right angle, but it's split into two smaller angles. So the first thing you want to do is you want to identify your angle type. In this case, we have complementary angles. Let me say that again. In this case, we have complementary angles. Now, second thing we should do is think about, well, what do we know about those? Well, we know complementary means that they sum to 90. So what that means is that these two together, x plus 68 equals 90. And so guess what? What we have here is nothing other than a very simple one-step equation. All right, don't overthink these. A lot of times it actually is that easy. Now let's take a look. I'll leave it up for a moment. Okay. Now let's take a look at example number 4. All right, example number 4, they give me two intersecting lines. So let's take a look at this, okay? Oh my God, so many variables. Y, X, Z, and 43. Okay, so first things first, let's identify what kind of angles we have. Because I have let me back up. Because I have two intersecting lines, that means that they automatically form two pair of vertical angles. Let me say that again. Two intersecting lines that form kind of like an X, they automatically form two pair of opposite congruent angles known as vertical angles. So if this is 43, so is this. All right, 1/3 done. Now, I'm gonna hide this for a moment. Can you guys tell me, do you notice how that's a straight line right there? How many degrees are there in a straight line? Anyone? Hint, hint, straight angle is 180. So if this is 43, to find x, all I have to do is 180 minus 43. So I turn that to a 10, borrow, and I have 137 degrees. If this is 137 and this is across from it, this is also 137. So that's an example of a problem, right? Where you actually have, in this particular case, two different theorems going on. You have vertical angles that are congruent. That's how we got the 43 and 43. But then you also have to use what are known as linear pairs, or you can think of them as supplementary angles, because these two add to 180 since they're on the same line. Okay? Alrighty, next up, let's take a look at question number 10. Once again, number 10. Alrighty, what do we got here? Ugh. All right, so I got two intersecting lines. So P, Q, R. Sorry about the bad handwriting, guys. And S and T, S, T. All right, then they actually give me some information here, don't they? So they give me PQT, that's 3x plus 47. Let me write that in. And then they tell me SQR, which is on the bottom here. Okay, so that's 6x minus 25. Okay, so remember, right? If they don't give you the information in the diagram, write it in. Now notice something. We gotta classify these angles. What kind of angles are these two right here? Well, I don't know about you, but because they're right across from each other, I'd say they're vertical angles, right? And what do we know about vertical angles from our last video? Well, I think we know that they're congruent, right? Or they're the same. So therefore, what we can do is we can say that 3x plus 47 equals 6x minus 25. I'm going to speed a little bit through the algebra here. Subtract 3x from both sides. So when I do that, I get 3x minus 25 over here. Then I'm going to add the 25 over here, and I'll actually show this step because I know sometimes people get a little confused, right? So what's that? 12, 1, 72 equals 3x. Divide both sides by 3, and I should get x equals 24. So yeah, okay. Problem though, is that what they asked for? sorry, no. What they asked for, what they asked for instead was the measure of angle SQR. So to find SQR, I actually got to take that 24 and I got to substitute it back in. All right. So to do that, I would do 6 times 24 minus 25. All right, what's 6 times 20? That's 120. And then plus this, that's 144 minus 25. I'm actually going to do the math out the long way. Okay, so it turns into a 14, and I'm going to borrow. So I have 119 degrees. All right. So again, what do all these problems have in common? At the end of the day, they really turn back into an Algebra 1, Chapter 1 problem. The geometry is really limited to the initial equation, right? The way I got the initial equation was by realizing that these are in fact vertical angles. If you could do that one simple step, it's all algebra from there. All right, and the last one that we're going to take a look at on page 17 is example number 12. Okay, let's take a look together at example number 12. So on the surface, number 12 actually looks pretty similar, right? They tell me K and M, so this one over here is 8x minus 5. And they tell me that M and J, so this one down here is 4x minus 18, right? Oh no, sorry, 4x minus 19. Whoops, that would have been bad. Okay, and they want me to find the measure of angle K and M. So they want me to find this one over here. Okay, now here's the thing. Even though I have intersecting lines, this is not actually a vertical angles problem. Instead, I'm gonna hide this over here. Well, I'm not gonna hide that. I'm actually gonna hide this. Do you notice how those two angles are on the same line? I'm not doing a good job of hiding. You notice how they're on the same line, guys? So because they're on the same line, they're a linear pair. Let me say that again. Because the two angles lie on the same line, they're a linear pair, and that means that they add to 180. So my equation that I would set up here is a little bit different. 4x minus 19 plus 8x minus 5 equals 180. All right? Combine like terms. Again, for those of you guys who are a little hazy on the integers, I lost 19 and I lost 5 more. So in total, that means I lost 24. Okay? To get rid of a minus 24, I'm going to add 24 to both sides. So I got 12x equals 204. Is that right? And I just got to divide both sides by 12. All right, so let me actually do my division here, shall we? 12 goes into 20 once, minus 12, 8. So I think that's 7. Yeah. All right, so I've got that x equals 17. Is that what they asked me for? Unfortunately, no. They actually asked me to find K and M, which in your diagram is actually right over here. So all I got to do is take that 17 and substitute it back in. And so I'm going to get 8 times 17. Let's see, that's 80 and 56. Is that 136? I think. Yeah. And 136 minus 5 equals 131 degrees. All right. So once again, big thing here is making sure that you guys can recognize your angle types. Do I have complementary angles? If so, add them, set them equal to 90. Do I have supplementary angles? If so, add them, set them equal to 180. Do I have vertical angles? If so, set them equal to each other.